So in the earlier lecture I talked about scalar and the vector potential. Now in this lecture I am going to talk about a retarded potential and the brief flavor of the what we call advanced potential, right? So I am going to talk about a retarded potential, So as we know that the current density, charge density, it gives rise to steady electric field. If it is constant, means if it is not changing, then it leads to steady electric field. Then if it moves, then it leads to or give rise to steady current. Current of, simply we can say that steady current density, that is represented by J, and the current leads to the magnetic field. So that means changing electric and the magnetic field. If we talk about changing electric and the magnetic field, then this leads to the propagation of electromagnetic wave. That means both this and J, rho and the J, they are changing with time and leads to the acceleration of the charge. So that means we have to consider the time dependence of rho and the J. So that means charge density will become this and current density will become this one, and we are considering their arbitrary motion. So let us consider the scalar and the vector potentials. This is the scalar potential as we have defined earlier lecture. There I have used R, but I am now taking it as X. And the vector potential I have defined as now the potential at X. From this expression, we are saying that the potential at X depends on the elementary charge located elementary charge means this is the elementary charge located at x prime. Now what I am considering that if charge is placed at x, if charge is placed at x, then it will take time x minus x prime divided by c to reach at x. Means it is the distance from x prime to x, and it is the speed because it's electromagnetic disturbance. Electromagnetic disturbance, it is traveling with the velocity c, in velocity of light. So keeping this thing in mind, so the potential will change, and if I want to find the potential at the earlier time, means earlier than t, so that means at time t minus x prime mod over c. If I want to find out the potential at this time, means earlier time, then the equation for the potential will become rho x comma t minus x prime by c divided by, and similarly for it can be expressed as, means for the vector potential, divided by x minus x prime, right? So that's what, and these two equations are known as retarded potentials, equations for retarded potentials. But if we have to find out the expression, or in the similar fashion, if we want to find out the potential at the time, later time, it's not earlier but it is a later time, so at that time these two equations will be expressed for the advanced potentials. And for advanced potentials, the above equations for the potential will become right. So these are the expressions for advanced potential. So that means now here I have defined the retarded and the advanced potentials in this lecture, and then I will use the idea of retarded potentials to derive the expression for Lienard Wiechert potential. So in the next lecture I will talk about Lienard Wiechert potential.